discuss, we're going to talk, we're going to bounce around some ideas until we get to the bottom of the question at the top of your page, which is, what is similarity? Actually, you've probably heard the word similar before. So I guess I want to add something. This is the first thing I want you to write. I want to add to this, what is similarity in math? In math class, similarity has a more specific, it still means similar. I don't want you to think that I'm just throwing that word out, but I might just extend it a little bit. Or maybe I'll make it a little more specific, what we mean by similar in math class. Okay? So here's some examples. And it says, see if you can find out using the clues below. Now, it says use a protractor and a ruler. I'm not going to do that exactly. I'll be your protractor and ruler here to look at these shapes. Now, I just want to look at these shapes. And they've given a bunch of examples. It says these two objects are similar. These two aren't what we call similar. And maybe you're already building a guess. Maybe that's enough right there to go, I sort of get the gist of it. But look, keep looking at all the clues. These two are similar shapes. These two trapezoid type things, clue number 3. Clue number 4, those are not similar. Okay, I'm going to go through them all, but then I want to get some measurements. I'm going to get a protractor and a ruler out on my screen and try to help here. These two, do you see the two cylinders there? Those ones apparently are similar, but these two objects aren't similar. Even though if I came in today and said, do you think those are similar looking? You'd go, yeah, they're sort of similar looking. No, from a math standpoint, we don't consider those similar. And then I got a really more basic one. Sometimes it's clue 7 and 8 that really brings it home. 7 and 8. These, clue 7, those are similar, but 8, those are not considered similar. Before I get my protractor and my ruler out, though, does anyone want to take a wild stab on it about what similarity means? What does it mean when it's similar versus not similar? And then I'll do some measuring to try to help and see if I can refine our ideas a little bit. Any ideas about what similar means after looking at those shapes? First hint coming up. Ready? I'm going to get out my protractor. Just watch me measure something. I'm going to go after clue 3. I think clue 3 is a very key one. Math tools, protractor. Here I go with the protractor, okay? And I want to show you something about shape 3. Here I go. Here's how you measure the protractor. Did you get to use a protractor in elementary school ever? Did they make you use protractors? A little bit, okay. So you know the gist of it. It just measures angles. If I go down here, I want to show you something about these two shapes. If I go down there and measure that angle right there with my protractor, it's right on 70 degrees. In that trapezoid, I don't want you to think you have to know the name trapezoid. You don't, actually. But that angle is 70 degrees. And if I go over to this little one, let me grab it and go over here and measure that angle in there. Can I get it on there just right? See how it's right along 70? 70 degrees. There's your first hint about similarity. There's only 2 things to know about similar shapes, but that's the first one. You see how the angle stayed the same? But then you look over here and go, there must be more to the definition because look, oops, I'm grabbing the background. Did you see that? Oh, I'll undo that. Got to grab just the protractor. Maybe I don't need the protractor. Do you see in the rectangles down here? Those are both 90 degrees. So it's not just the angles. We need the angles to be the same. That's what makes a similar shape. In fact, look at the T's at the end. I think those are interesting too. Look at the T's. The angles are clearly the same all the way along. But they said these aren't similar. What's different about the T's? Why is 8 not similar but 7 is? Proportion. He's used the perfect word. By accident or on purpose, I don't know. Because as soon as we say the word proportion, hopefully the way I've set up the chapter, your eyes sort of light up, your ears sort of jump in and go, proportion? We're just going to use proportions here? Is it cross multiply? Are we going to be able to cross multiply? And the answer is absolutely. By the time the lesson's over, cross multiply is going to return. And we're going to just use cross multiply to do all these questions. But we can see by looking at it that the proportions in this are not the same. This is I'll just make one little note on your note. We're not going to write too much here. This is too short. It has to be the same shape. But it can be bigger or smaller, yeah? Look at this one. Look at clue 6 now. Do you see what I mean now? All the angles are the same. But do you see it's not in the same proportions? Like this was a tall. This was tall. This was wide. Not similar shapes. We need the same shape if we want to be similar in math. Okay, same proportions all the way through. Is 2 obvious? Look at 2. These are not the same shape. You know what I imagine? Sometimes teachers, we photocopy things and we blow up an image. We make it bigger or smaller. Yes? Sometimes you've seen a picture of something, right? I can show you a picture on the screen of the CN Tower. It's still the CN Tower, even though it's not as tall as what the actual CN Tower is. We want to keep it the same shape if we're going to be similarity. It's sort of the basis of mathematics, how we can do math on a page without going out to the CN Tower. That is, you can do calculations about the CN Tower without having a diagram that's 530 meters tall. You can make it smaller. As long as we keep the shapes the same, it's all going to work out. Let me transfer that into words. I don't want to belabor the point, because I don't want to make this out like there's something really difficult going on here. Let me get rid of the protractor. Whoop, right in there. Did you get it? What do you think similarity means? I'm going to keep this brief. Brief. I don't know if your English teacher would love what I'm going to write here. I'm just going to write just the words you need to understand what's going on here. So hopefully you copy it down and reference it. What do you think similarity means? Yeah, the same, and I'm going to put it in quotes, shape. Because someone might complain that there was some there that were the same shape, but they weren't really the same shape. So I need just a little more here. Angles stay the same, and I cannot resist. It is too good a word not to use, even though I'm trying to be clear and brief. Sides stay proportional. What a great word he used there. It's a great word because it means exactly what we need here. But it also is a great word because, and again, I want you to picture this. Again, I was coaching 8-year-old hockey on the weekend. Nuts. They are nuts. Nobody has more fun playing hockey than 8-year-olds. They come off the bench, falling down, tripping over each other, flying out. As soon as I write the word proportional, cross multiplies, jumping up and down on the bench going, I can help. Cross multiply. You know what a cross multiply? I can do these with cross multiply. Oh, we've got cross multiply. Formal definition of similarity. Here's it in math terms. Yes? I'm happy with those terms. If I ask you on a quiz or a test, what does similarity mean? If you write what I did in the first box, I love it. But here's the formal definition. There it is in fancy math terms. A similar shape is one that has had sides scaled by the same factor. I almost wrote scaled up, and that's not true. They could be scaled down as well. Scaled by the same factor with angles preserved. I want to show you what I mean. Let's get a photo of the CN Tower. And I'll put it on the screen. Does everybody know the CN Tower? Has anybody been up the CN Tower? Yeah. Yeah. Okay, here I go. I'm going to get the CN Tower. Okay, do you see the CN tower? Is that the actual size of the CN tower? No. No! Of course it isn't. I've scaled it. I've scaled it down to something I can deal with. But you get the idea of the shape, right? All the angles have been preserved. It's proportional. Yeah? Shows that it's a long way up to that center one. And then you can take, if you've never been on it, then you can get on another elevator, pay extra money, wait extra long, and go all the way up there. It's a little underwhelming, I must tell you. It's boring. It's so unreal. Like I think, like if you stood on the top of St. John's, don't do this, and went out to the edge, you'd be like, whoa, oh, scary. It's almost not scary when you get up that high. It's so weird and unreal looking, so don't feel like you're missing out on too much. Anyways, here, watch this. This is my real moment coming here. I'm going to duplicate that. And take this CN tower over here. Huh? Same shape. Same shape. Yeah? Just been scaled up. But watch this. I can make it not similar. Watch this weird move. I don't know if you know this about computers. If you grab this one, do you see it's different? It's got an angled line there. If you grab that one, it keeps it proportional. It's still the same shape, but you don't have to do that. Watch this. Do you see that? Not proportional. I've messed with it a little bit. It looks wrong now, doesn't it? It's like, it's skinny now. Not similar, right? So let me do one more. I'll duplicate that again. I'll take it over here, and I'll go here. Similar. And then not similar. It's just a blown up version of it, okay? By the way, let me go back to what I said at the start. I don't think today's a particularly hard lesson. I don't think what's going on is very difficult here, but it does take some explanation. It does take a little bit of guiding you through it. And remember, I promised no homework. We're going to do it all together. Here's another way to write the definition. You have a giant page for this, right? I'm going to make myself some space and also do a little demo at the same time. I'm going to make my shape not similar to yours. It's not similar. I stretched it up. I bought myself some space. I'm not going to write too much here. I'm not going to write too much. I want to use your definition. Can somebody, in their own words, let's say somebody just got here or was late or something. What would you tell them? Similar triangles. What would two similar triangles be? What words would you use? I want to use, like I really do want to use somebody else's words, not mine here. Somebody's got an example. Yeah. Two triangles. I'm just going to add a couple words here, okay? Two triangles that are proportional. And let's just dive into that word proportional a little bit. It means, and I'm going to go over to properties and characteristics. Sides all scaled by the same amount. You want to double? Fine. Double everything. You want to triple? No problem. But triple everything. Keep it all proportional. That's what proportional means. It means we use the same multiplier on all the side. Examples. Okay, you got to watch this carefully here because I'm going to make a triangle over here. Yeah? And now I'm going to try and use my active board. Oops, that's not what I meant to do. I need to use the camera tool on my active board to make a copy of that triangle. You can just draw it. You don't, I'm just playing around here with my active board. There it is. I made a copy of that triangle. It's not a very good copy. And here it is. You just draw a bigger version of it. Ah. I don't know how big I scaled it, but you see, I pulled it along the right side now. It's all the same proportions. Non-example. Ooh, I'm going to use the same triangle. going to duplicate that thing. Are you ready? You can do it however you want on your picture. Watch this. Do you see it's not the same? It's still a triangle. And I'll just write in here, in weird fun letters, too skinny. I'm not trying to get all technical here. I'm just trying to go, okay, this is what we mean by similar triangles. But I'm going to add the most important piece right here. One more thing to put up in properties and characteristics. So I'll put it in capital letters. All angles stay the same. So your angles between different parts, or in this case, the three angles in the triangle have to stay all the same. Can you see in the picture the angle change? By making it too skinny, this angle here, I'll get my protractor back out and show you what I mean. This angle here in this triangle, down there, and I put that right there, looks like about 45 degrees. Yes, I made about a 45-degree triangle. Would you agree it's not going to be 45? Oops, in my similar one. Got to just grab the protractor. I don't know if my picture is good enough to be able to get this. Yeah, it looks like 78 degrees. That's the big thing. I changed the angle. That was all part of it becoming too skinny to be a similar triangle. Let me just say it again. If you're like, this seems pretty straightforward to me. Yeah. I made no promise that this was going to be difficult. All right, now I promised we were doing this all together. So what I want you to do, there's 3 on the next page. This was supposed to be, you know, sort of a homework thing or an investigation, but we're going to do it together. Do you need more time here? Did you get down all angles are the same? I want you to take, here's what we know about similar triangles. Sides proportional, angles the same. If you're bored with writing those 2 sentences, good. Then I've done my job today, because those are the 2 defining features of similar triangles. Sides proportional, angles the same. So on the next page, I want you to look at there's 3 sets of triangles. I want you to decide for yourself, with a partner if you want, if you think the triangles in question are proportional. We'll start with this pair here. We can just work on that if you want. Just look at those and decide if you think that either you know the sides stayed proportional, or you know the angle stayed the same. I, on purpose, selected what I hope is a pretty easy one. Did the sides stay proportional? What's the multiplier? 2. Let's see. Does this side here double? By the way, this is great triangle thinking here that I did. That's double. That's double. So the third one has to double as well. Once 2 of them are doubled, that third one's got to double, because it's still a right angle triangle, right? Pythagorean theorem, and we haven't discussed the Pythagorean theorem yet, would be double. But can I look at it and go, this diagonally goes through here, this diagonally goes through that distance there, and then it does it again. So it doubles as well. Similar. Sides proportional. Which brings up something I didn't mention, really. If the sides are proportional, the angles will be the same. And if the angles are the same, the sides will be proportional. So we don't have to do both. We don't need a protractor here. We see the sides are proportional. Good. We know they're similar. That's enough. It's one or the other. Questions there? We'll do another one. Oh, this is harder. This is harder. Yeah, we're going to need, just take a minute to stare at it and see if you can decide whether the sides are all proportional or not. If they are proportional, what's the multiplier? Take a look here. AC, how long is AC? 1 square. How long is CD, the bottom of this triangle? Let me highlight it on there. 1, 2, 3. If it is proportional, the multiplier is 3. Yes? Does it work? This might take a little staring at this to decide. Take a look. Take a look at this side here. I got to get the right side highlighter. Do you see that side there? Do you see it goes over 1 up 2? It's slope. Let's see how many times this one does it. It goes over 1 up 2 once, over 1 up 2 twice, over 1 up 2 3 times. Oh, it is triple. It does that slope 3 times. That one's times 3. I've used my crazy red highlighter there by accident, but I like how it looks, so I'm going to leave it. How about this one? This one goes diagonally. Look at diagonally 2 squares. Does this one go diagonally? Let's get the highlighter out. Diagonally 2 squares? Yes. Then it goes diagonally 2 squares a second time? Yes. Diagonally 2 squares a third time? Yes, it is triple. What's my word then? They were all multiplied by 3? Is it similar? Yes? And what's our reasoning? Right, sides are proportional. So if it's similar, the sides would be proportional. We could have done it with angles, by the way. We could have measured the angles, and you would have found that the 3 angles were the same. But I'm not trying to get sidetracked by protractors necessarily, you know, if we can do it without triangles. Maybe you want angles. Do you want more angles? One more example like these. Do you need more time here? Are these proportional? How long is this side? Right there. AB is length 2. Now I'm just starting to do the math now, to write it in a math way. That side is length 2. How long is DE? How many dots? How many squares between the dots? How many of these little side?
5.
Oh, I know why you're saying 5. Yeah, because you're counting the dots. But look here, let me count them. 1 space, 2 space, 3 space, 4 spaces. DE is 4. So it looks like double the length. If this is proportional, they're going to all be double the length. You're counting between the dots. You ask a good question. You sort of don't count your first dot, because the first dot is where you start. So you're counting every step on the dots. Yeah, no, that's a good question. Count how many steps on the dots. Now the diagonals are different though. We have to sort of use this slope thing. Look at, on this one, over 2 down 1. This one goes over 2 down 1 once, and then it does it twice. And this one does it the opposite way. So these have the same length going that way. So Now, if those symbols seem a little weird, or how I wrote that seems a little weird, yeah, I know. I'm getting ready for the math on the last page. When we get to, if you just page ahead to the one that says 4.4.4, we've got to start using these letters to figure out what's going on. We're going to do it together, though. Our first time through. We're going to do all 6 of those together, and then we'll be done for the day. Like, we might be done early today. Because today was just like intro to the word similar. It's all meant to give you a feel for what similar means. I'll get you to do some ratio work, though, on those 6 examples, though. All right, let's switch over to houses. Instead of just triangles, let's talk about houses. There's 4 shapes there. I want you to take a minute and decide which ones are similar. First, just stare at the shapes. Stare at the 4 houses and see if they are the same shape. Or which ones are similar. Then we'll compare. Take a couple minutes. I'm going to stare at it too and really think about what I'm going to say about it. Yeah. I have thought about it. I've looked at it carefully. I've decided that I've figured out which ones are similar and which ones aren't similar. Is it easy? If it's easy, then we're in great shape. Then we've done our job today of figuring out, well, half our job. We've done half our job of figuring out what the heck is similar. Katie, which 2 are similar?
Putting me on the spot. Okay,
2 and 3. Can you, in your own words, though, help us out. You're right. So now you can feel confident, like, okay, well, I'm right. Now I just got to find some words to help out somebody who was like, I'm not sure how she knew that. How did you know? The other ones look weird. Perfect. It's a perfect answer. It's clear. What's wrong with number 1 then? It's too high. Yeah, it definitely goes too high. Because, and I'm going to start putting the math in for you here, it's just as high as 2, but it's not just as wide as 2. There's no way that can be right, to be similar to it. It can't be the same height, but not the same width. So how does 4 fail? Yeah. So you said long, but I mean, some people might use the word wide, but I like long, it's fine. It's the same width as 2, but it's not as high. So it's like it's too short as well. So let's focus on 3 and 2 then, and start getting some math ready for this, okay? How wide is 3? Right there. 2. How wide is 2? 4. So if it is proportional, what number has it multiplied by? 2. It's been multiplied by 2. Let's check. The height of the little first floor there is 1. The height of the first floor here is 2. Looks right. Yeah? And then the height of the little peak here. Does anyone know what this peak is called on houses?
Roof.
The roof. The height on that one is 1. The height on that one is 2. So it is doubled. All proportional. And getting a little deeper knowledge of the word proportional. Proportional means you've doubled things, or you've tripled them, or you've quadrupled them, but you'd use the same multiplier all the way through. Does that help a little bit on proportional? And what does it say to do? On the grid, draw a house that is similar to one of the figures. Ooh. Which one do you want to do? Let's leave 1, 2, and 3 out of it. Let's do a house that's similar to 1 or 4. Which one do you want to do? 1. We're going to do a similar house to 1. What multiplier would you like to use?
2.
He wants to do 2 again. We're going to double house 1. Okay? Where am I going to fit it? I'll try and do it in the bottom right corner here. So if we're going to double it, how wide will the bottom be? 4. So it's got to be 4 wide. I'm going to call it the first floor. How much will the first floor go up by? These little side things on 1 go up by 2. What am I going to go up by? We doubled. They're going up by 2. 4. Maybe you meant the whole height, did you? Yeah, I think you did. 1, 2, 3, 4. 1, 2, 3, 4. I declare a thumb war. How tall is the peak going to be then? The peak on 1 was too high. I've got to double that to 4 high. I'm going to write that on there. And there's my peak. Does that look, Katie, does that look, what was the word you used? Did you just call it weird?
Yeah.
Does this look weird now, comparison to that one? Does that look like one?
Yeah.
Yes, it sort of does. It's sort of got the same shape. Like it's sort of tall and skinny, right? This one's sort of tall and skinny, sort of like I did with the CN Tower, right? So I'm just going to label that similar to 1. Now he used a multiplier of 2. You don't have to use 2 every time. We've been using a lot of 2s. The multiplier could be anything. It doesn't even have to be a nice number. It won't matter. We've got cross multiply ready to go. If the numbers aren't nice, cross multiply is going to take care of it for us, no problem. Could be a decimal, yeah. But again, I won't, if you're like, oh no, here we go with decimals. No, cross multiply is like, don't worry. Don't worry your head at all. I've got the decimals, got the fractions. If you got your calculator ready, as long as you know how to cross multiply, we'll be home free. Oh, so what did we do? We got to answer the questions here? We did it. On the grid, draw a house that's similar. The house I drew is similar to house number 1. I know this because I doubled everything. And again, we're not stuck to doubled. We did a lot of doubling. Maybe I should have pressed a little bit and gone, oh, can we triple something? Can we quadruple something? But any multipliers allowed, including decimals, including numbers that make them smaller. We don't have to go bigger all the time. We could have gone smaller. That's supposed to be enough to me to stop and say, oh, why don't you try this, do your homework? No. Let's do these questions together. There's enough work there that we can work our way through it, and we won't be done that early. Jackson? Sure, let's do a couple together first to make sure we sort of got this down pat, okay? C. Use a proportion to find the unknown length in the pair of similar triangles. Now look, they said it was similar. They said it was similar. We don't have to try to figure out if it is similar. They said it is similar, which means I'm going to write a big word there. Please write this. As soon as they say that, we know it's proportional. Now I'm going to do this one without bringing in cross multiply. I'm eventually going to bring cross multiply when I need it. I don't think you need cross multiply here. It says KL is 9 meters, AB is 18 meters. What's the multiplier? How much bigger is the second triangle than the first? Not by the picture. They're just on the picture, they're just showing what's going on. I know the picture's not really showing off what's happening here. But what did KL get multiplied to get to AB? What are you multiplying 9 by to get 18? So this is another doubling situation. I went right back to doubling. So to go this way, we doubled. Knowing that, and stare at them, because I'm trying to get used to these letters. Stare at what I'm saying. How long is KJ then? Get your own guess in your mind, then Jack's going to answer, because it's easy to get a wrong answer here if you do this the wrong way around. Jackson, what do you got for KJ? 6 meters. That is correct, so don't let me throw you off here. You're going to argue with me. You ready? You ready to argue with me? Yeah. Okay, I'm going to say, wait a minute, I thought we said it doubled. Shouldn't it be 24? It doubles the other way. Yeah, so if we want to go this way, we need to half what was there. You're like, oh, do I have to keep track? Well, yeah, maybe. But better yet, cross multiply is waiting. Cross multiply coming soon. I'll use it when I have to. It's coming up. I'll do ABC without cross multiplying. And then I'll do DEF. DEF, as soon as we're in trouble, we're like, ugh, cross multiply. Ready? Well, okay, is this one difficult? How long does JL have to be then? 7.5. Because I have to come this way. You're like, so everything in the world doubles? No, I just done a lot of doubling to give the idea. What's the multiplier here? To go from 6 to 18. What did they multiply by? 3. Now, the blaring question in your mind should be, how am I supposed to know that number? What if the number is bigger, too big for me? Yeah, maybe I can do 18. Well, what would you do with 18 and 6 to find out what was multiplied? What operation can you do to figure out what was multiplied? We want to find out. He said someone said it was multiplied by 3. But you look at that and go, I can't tell that's multiplied by 3. Or I'm worried about big numbers. What could you do with the 18 and the 6? What operation can you do to find out what the multiplier was? Division, yes. 18 divided by 6 is 3. And we're almost cross-multiplying now. We're almost back to building a proportion to do these. So if it's multiplied by 3 every time, take a shot. Either with your calculator or do the multiplication. Try and challenge yourself to find, if we know they're multiplied by 3, try and challenge yourself to get the answers all the way down here. I'll fill them in. You try them in your head. Try and multiply them each by 3. I'll keep filling them in. Oh, this one's easy. Hopefully you could do this one at least. 7 times 2. What's 7 times 2? 14. But it won't be long before the numbers get where you're going to need your calculator or you're going to need cross multiply, okay? It's coming up. Question? No, it's good?
Question. Why did I go from, so 9 and 3, you times that by 3.
Yeah.
9, and then.
Oh,
You did it.
yeah. I went back to doubling. I totally went to sleep there. Thank you. Oh, I would have been so sad if I left that on my video. Yeah. I totally went to sleep. We did so much doubling that I just started doubling. Yeah? Easy to do. It's tripling. So this one's 15. And this one's not 14, it's 21. Thank you. Great catch. And thanks for speaking up. Woo! Losing it here. On what day of the week is it? Is there an excuse? Oh, Monday. That's why it's Monday. Pretty makes a mistake on a Monday. Folks, we're almost done. We're going to do C, D, E, and F. I'm going to do C again, just trying to use my brain. And then after that, we're going to bring out cross multiply. And I'll show you how to do cross multiply. Okay, C. What's the multiplier? It went from 2 to 8. 4. How do you get that in your calculator? Let's say somebody didn't know. You just do 8 divided by 2, okay? So if these numbers are weird, you can always get the multiplier by dividing. Always. So, FG is 6, so what's NO? How did you do that? You just knew? He divided by 4, but maybe you need your, this might be the one where it's like, I don't do divide by 4 in my head. I need my calculator. I know, cross multiply is jumping up and down now on the end of the bed. Coach, put me in. I can handle this. I can line it all up for you. I can take care of the decimals. Oh, this one's not bad. And then this one, we already got the other one, so that one came through. But that's like the limit now of just thinking these through. Let me show you what I mean here. Get ready. If you fall into sleep, I get it. But you might want to come back for these last 3. Like if you've literally... Wouldn't that be awesome? Wouldn't that be the greatest? We just all leave. She wakes up at 4:30. All right. Here's how you do with cross multiplying. This is what you really came in for today. The rest of that was just a lot of talking. And I get it if you're bored. I do. I had to explain all that, but I get it if you're bored. Here's how you do it with cross multiplying. It's awesome. You're going to love it. Watch this. I say OP over CD is equal to MN over AB. Now, that looks completely weird. And I think I heard someone say the word gibberish a minute ago. If that looks like gibberish, just look at it for a second. 18 over 54 and x over 36. You may be like, oh, I like his way better. I don't like when you write all the letters like that. I'm fine with that. I really am. I'm just trying to show what I did. I just said, okay, now why did I select OP and CD? Why did I select these two? We know both of those. So let me put little smiles beside that. I know this one, and I know this one. And so that's what I'm going to need if I'm going to set up a cross multiply proportion. Then I choose another pair, any pair you want, to find out what the other proportion was. Then you can do your cross multiply that you loved. Yes? 54x. And then you find out what 18 times 36 is. What's 18 times 36?
It's 648.
648. And what's the opposite of multiplying by 54? Divide by 54. And what's 648 divided by 54?
That would be 12.
12. Ah, I can fill that in. What was after? This one, 12. Now, can anyone explain that without my silly, no, it's not silly, I shouldn't have said that. Without my powerful cross multiplying? Without cross multiplying, can you see what just happened there? 54, it's all times by 3. So maybe at some point during the question you go, oh, I see what the multiplier is. And you could do that if you wanted. But the cross multiply is like anytime there's trouble, cross multiply is ready.
So basically, what we want to do is find the multiplier.
I like what he said. Let me just put that in quotes. So basically, find the multiplier. Yes, and that's a very good definition. Jackson, you want to come up and sign that? It's a good quote. He's going to put his signature there. Or you can just put your initials if you don't have a signature. Do you have a signature yet?
Yeah.
Oh, here it comes. Beautiful. That's good.
It says my name.
So basically, find the multiplier. So what is the multiplier here? What are you multiplying by? 3. So once you have the multiplier, maybe you don't have to do this anymore. You're like, oh, I see what's happening. It's multiplied by 3. So then you go, okay, take this one and multiply by 3. 17 times 3, you punch in your calculator, you get 51. 8 times 3, you get 24. So I'm trying to mix and match here. I'm not trying to say it all has to be cross multiply. Cross multiply is there when the numbers get a little weird or decimals start to get involved. You got cross multiply available. So I think I told a lie. I'm going to do E. I'm going to leave F for you only, okay? You just try one question on your own. That's the only homework you have. We'll do E together. Does anyone think they can set up the proportion to figure out, oh, both answers are going to be the same, aren't they? To figure out the unknown. What's the first fraction in the proportion? Who's ready?
40.
40 over 30 equals 60 over x. Bigger over smaller. Bigger over smaller. At least do that much. You don't have to do this, write all the sides out if you don't want, but make sure bigger over smaller, bigger over smaller. Then cross multiply, 40x. I don't see any 50s. Oh, it's awfully tempting to go, oh, it's going to be 50. But when it's multiply, it doesn't necessarily do the same thing as with add. But let's check it out. 1800 and 1800 over 40. What's 1800 divided by 40?
That would be 45.
45. Yes. It's, what is it dividing by? Or what is it multiplying by? Okay, let's check that out. Let's try and find the multiplier. The multiplier is, oh, there's the multiplier, 0.75. Do you want to do it with a multiplier in this case? No. Cross multiply. Yeah, okay. Try F. We'll take it up in a minute. I'll set a 3-minute timer. Those of you in the video can fast forward 3 minutes. Set a, 4-minute timer.
4 minutes.
Take 4 minutes and see if you can do F. And if you do F, then you can do number 2. Then we'll take it up. Then we'll be done. Look what time it is. Done, done. See if you can do it. Set up a proportion and try it out. Okay, yeah. Some people want a hint. So if you don't want a hint, continue on your own. If you want a hint, here I go. I'm going to do I knew the 70 and the 56. Right? So I'm going to kind of circle that. I don't mean circle like the butterfly cross multiply thing. Like, there's a set I know. There's 70 over 56. Which one do you want to go after then, after that? The first one. I don't know AB. But I do know MN. Does that help? Try that out. And if you had trouble with that one, no problem. Just do the cross multiply and get that answer. And then you try and set up another one. It's always going to be 70 over 56. That's the one we're going to.
Does it matter where you put the x in the fraction?
Yes. If you put the higher number in the top here, make sure the one that's going to be higher is in the top here. So 70 over 56, I knew x has got to be the bigger number. So I put it as the higher one there in the numerator. So you do have to match those up so that you get bigger numbers. Yes, I'm going to wrap it up in a second. I'm going to return tests, updated marks, everything. That's another reason why it's nice this lesson ends up being short. I don't think so. What happened here? 56x equals whatever 70 times 32 is. What's 70 times 32?
2,240.
The answer is 2,240.
And then you take the 2,240 and divide it by the 56. 2,240 divided by 56?
The answer is 40.
40. Let's try another one. I'll switch colors. 70 over 56. That's the part I knew. Does the 60 go in the top or in the bottom?
I already know the multiplier.
Oh yeah, what's the multiplier?
1.25.
Good for you. How did you get it?
My best friend.
He's calculator. What's 70 divided by 56?
It's 1.25.
So you could get the multiplier as well. I'm not saying cross multiply is the only way to do these. Getting the multiplier totally works. So he went 70 divided by 56 and got the multiplier of 1.25. Now he's got to be careful. If I'm going to go from here to here, he can just multiply by 1.25. That works. That direction. What's 16 times 1.25?
The answer is 20.
But if he wants to go the other way with the multiplier, what's he got to do? Divide by 1.25. What's 60 divided by 1.25?
The answer is 48.
Okay. So I showed cross multiply, which we're going to do more of. This isn't the end lesson. This is like intro. Let's just tiptoe into similar triangles a little bit. And so lots more of that coming. You have only one thing to do for homework. Question 2, it says, were there any questions that were harder to determine than others? And then if so, why were they more difficult? Why were they more difficult?